Okay, in this video we'll continue with Larson Chapter 4, Section 1. We do have a new vocabulary term in this section of problems, and that is an indefinite integral. And an indefinite integral has a function as a result. A definite integral gives you a number. Just like with derivatives, a derivative can be a function that returns the slope of the tangent line for any x value, or it can be just a specific slope of a tangent at a particular x value. So just like with derivatives, derivatives can be values, constants, or they can be functions. So integrals can be functions, which is an indefinite integral, and constants or numbers, which are definite integrals. So again, an indefinite integral has a function as a result. Later on we'll see definite integrals, and their result is just a number. Alright, so let's take a look at number 15 here then. For number 15, we want the integral of x plus 3 dx. Now, integrals, just as with derivatives, the integral of a sum or difference is equal to the sum or difference of the individual integrals. So we could split this up into two different integrals. Integral x dx plus 3 integral dx, or maybe the first time integral 3 dx. So a couple of things to pay attention to here. We can do each of those antiderivatives without doing separate integrals. And second of all, a constant multiplier can come out through the integration symbol. So this is just like integral x dx plus 3 integral dx. One of our properties of integrals tells us that integral dx, which can be written as integral x to the 0 power dx, which means it's really 1, right? Can be written in that way. Now we can take each individual integral separately. So x to the first power increased by 1 gives you x to the second over 2. Then x to the 0 becomes x to the 1 over 1, which is just x times 3 is 3x and plus c. Alright, so we won't go through all of that trouble for each of these here. They're really not that complicated. Number 16, we have integral 5 minus x dx. So integral of 5 is really the integral of 5x to the 0 power. So increase by 1 and divide, so that's 5x. Then minus integral of x is going to be x to the second over 2. Then the plus c, and that's it for that one. We'll go on to number 17, and that is integral 2x minus 3x squared dx. We'll take the first term, 2x to the second over 2. That's just x to the second. Then 3x to the third over 3, and that's just x to the third and plus c. Now if you wanted to, and I haven't been doing this, check the result by differentiation. You could simply take the derivatives of each of those answers, and you should get back to the original integrand. Okay then, number 18. We have the integral of 4x cubed plus 6x squared minus 1 dx. So that would be 4x to the 4th power over 4, or simply x to the 4th. 6x to the 3rd over 3, so that will be 2x cubed. Then minus 1 x to the 0 is going to become negative 1 x to the 1st over 1, or just negative x, then the plus c. Number 19. And 19 will be integral x cubed plus 2 dx. So that is x to the fourth over 4 plus 2x to the first over 1, or simply 2x, then plus c. Alright, we come to the final number 20, sorry. And number 20 is the integral of x to the third minus 4x plus 2 dx. We'll do each term individually. X to the fourth over 4 minus 4x squared over 2, so that'll be 2x squared, then plus 2x to the first over 1, or it's simply 2x, and plus c, and we're all done with this set. And ready to go on to the next set then. So we'll stop this video at this point.